بسم الله الرحمن الرحیم. سلااو قوتابیانی خۆشەویست. دەست دەکەین بە تەواوکردنی chapter 4 کە لە section 2 وەستاوی. Section 2 in chapter 4 is specialized to study driving forces for the reaction, or we're going to deal with the forces that are going to drive the reaction to occur or to prevent them from occurrence. Well, we have some factors that are affect on the reaction occurrence, and we're going to deal each of them individually, inshallah. Two factors that allow chemists to predict whether a reaction will occur spontaneously or non-spontaneously. Okay, we have two factors that help us to predict that the reaction will occur spontaneously or non-spontaneously, which are delta H and delta S. Actually, we have three driving forces of the reaction, which are delta S, delta H, and delta G. According to delta S, according to delta H and delta S, we have to know, according to delta S, which reaction, okay, favors spontaneously, or which direction will be favored. According to delta H, as you know, we have exothermic and endothermic. Which one will be spontaneously? According to delta S, we have negative and positive. I'm sure that you don't know nothing about delta S, but you have more information about delta H. So don't worry, we will study delta S also. Each of them, they can result positive value or negative value. So we have a plan to predict the spontaneity of any reaction according to the sign, arithmetic sign of delta S and delta H. Okay? So how we can predict the spontaneity of any reaction according to these factors? So from now on, how many driving forces do we have? Three: delta S, delta H, and delta G. According to delta S and delta H, the decision is uncertain. It's uncertain. According to delta S and delta H, the decision is uncertain. But according to delta G, the decision will be certainly. Okay? So be careful with these words. These are very important. According to delta S and delta H and delta G. Okay, let's write name of each of them. This is entropy change. Entropy change. And it's enthalpy change. Enthalpy zahanzi. Okay, delta G is gives free energy. Gives free energy change. So now I think you are a little bit familiar with the driving forces. We have three forces. 1, 2, 3. Okay. We will study the spontaneity of a reaction according to each of them individually. Then we are looking for the certain answer. Which one the decision will be certainly, of course, gives free energy. So let's go through this subject deeply. First of all, we have to study enthalpy. Enthalpy of a reaction, enthalpy and reaction tendency. It means how enthalpy affects a reaction to occur or not. The great majority of a chemical reaction in nature are exothermic and spontaneous. Look, we have two types of enthalpy. Negative enthalpy, which is exo, and we have positive enthalpy, which is endo. So, for any reaction, which one is favored to occur? Of course, exothermic. So, reaction in nature, okay, they like to be exothermic. So the reactions in nature that are exothermic they are occur spontaneously. If a reaction is exothermic, it will be spontaneous. Exothermic reaction is spontaneous. Exo, spontaneous. Negative is spontaneous. So that means a positive value will be non-spontaneous, which is endothermic. In exothermic reaction, reactants, as you know, reactants have more energy by comparing to the product. Okay, this is not new. The product have less energy. Okay, you know this. Most scientists believe that the endothermic reaction, which absorbs energy, will not occur spontaneously. But let's take a look on melting of ice. Okay, melting of ice. Melting of ice. Melting of ice. If you put a piece of ice in anywhere, it's going to be melt. It's going to be melt spontaneously without increasing temperature, without anything. And at the same time, so melting of ice, it's spontaneous. But it's exo or endo? It's endo. But mister, I remember just before a minute, you've told us that endo, it's non-spontaneous. Why it's spontaneous here? Ah, okay. So that means if we think about melting of ice, there is another force that drives this process to occur, right? So delta H, it's not the only driving force, because we have this one, which is reverse with our rule. We have said that according to enthalpy, only those enthalpies that are negative, okay, will be spontaneous. But here we can see that delta H, it's positive and it's spontaneous. So that means there's another force that affects this process, which is called entropy. Entropy, S. What is entropy? So we have finished with delta H, and now we're going to study delta S. What is entropy? Entropy is a measure of the degree of randomness of any particle in an identified system. It means if you have a system, of course, a system in chemistry, it means reaction, it means equation, reaction, right? Any experiment we call system in chemistry. So the degree of randomness of the particles can be measured, can be expressed by entropy. Okay, so let me give you some detail about delta H. Delta H, if it's positive, if it's negative, okay? If it's positive, it means to have highest energy level. Energy level. But negative, it means toward less energy level. So according to enthalpy, that's enthalpy, heat of reaction, okay, which direction favors toward less energy level? It means exothermic. So if we have exothermic reaction, it's spontaneous, but it's non-spontaneous. But the result, it's uncertain. So it's spawn, but it's non-spawn. So that means if we want to decide that the reaction occurs spontaneously or non-spontaneously, according to enthalpy, if it's exo, it's spontaneous. If it's endo, it's non-spontaneous, but the result, it's uncertain. And I'm sorry, uncertain. With my wonderful handwriting, uncertain. Okay, uncertain. And according to entropy, we have delta S, change in entropy, entropy change. It's entropy change. And it's enthalpy change, of course. Nice. Entropy change. Entropy, we have two types of entropy, positive entropy, negative entropy. Okay? This is increasing what? Increasing randomness. But this one is decreasing randomness. Okay. So which one is spontaneous? Which one is non-spontaneous? Increasing in randomness, it's spontaneous. Spontaneous, but this one is non-spontaneous. Again, the result is uncertain. Uncertain. It's uncertain. The result is uncertain. So, Mr. Now, please just make a quick revision. Okay? Well, look, we have enthalpy, two types of enthalpy, positive and negative. Positive called to have highest energy level. It's non-spontaneous. According to delta H, negative enthalpy, which is exo, toward less energy level, spontaneous, but the result is uncertain. According to entropy change, if we have negative entropy, it means decreasing in entropy, it's non-spontaneous. Positive value of entropy, it means increasing randomness, it's spontaneous, but the result again is uncertain. Very good. Entropy can be defined as a simple qualitative way to measure the degree of randomness, the degree of randomness. So how we can measure the degree of randomness of particles in a system, of particles in a system, of course, according to entropy. But as you know that we haven't studied H, we have studied delta H. For S, it's same, we're going to deal with delta S. So delta S, entropy change, which can also be the difference between entropy of the product and the reactant. Delta S, it means, look, we have here very nicely, delta S, S of product minus S of reactant. So we have two types of delta S, positive and negative. For positive, it's spontaneous. For negative, it's non-spontaneous. Right? It means increasing randomness, but this one, decreasing randomness, right? Increasing randomness and decreasing randomness. Increase in entropy, it means high randomness, increasing entropy, high randomness, increasing randomness. So it's spontaneous, decreasing in entropy, negative value of S, it's high regularity or less randomness. Actually, regularity, it's informal according to our chemistry course. We haven't, we are not going to use regularity, but we can say less randomness. Less randomness. Cool. Entropy of precursor is 0. This is just note. So now how to identify the arithmetic sign of entropy? Look, according to enthalpy, we know that if we have this type of reaction, A plus B, look, A plus B, to producing 2C plus kilojoule. Because we have kilojoule, it's delta H, with the product reactants, it means it's exo. So according to enthalpy, it's spontaneous. But how we can identify the arithmetic sign of entropy change? Okay, it's very important. My dear students, if we have a reaction, how you can identify the arithmetic sign of entropy? How you can assay, how you can measure the arithmetic sign, how you can detect the arithmetic sign of delta S. The first step, you have to focus on the physical states, okay? Physical states are very important that we can identify delta S's arithmetic sign very easily according to physical state. Look, we have three states, as you know. We have three states. Very good. The first one, look, we have solid, liquid, and gas. Solid, liquid, gas. Look, conversion from solid to liquid called melting. These are physical changes. These are physical changes. Okay. Conversion from solid to liquid called melting. Right? And melting, delta S is positive. Look, if we compare particles that present in liquid to the solid, which one moves faster, of course, from liquid? So which one will be high random? Of course, in liquid. That means it's increasing in randomness, so delta S is positive. And from liquid to gas, the movement of particles will be increased, right? Will be increased, so will be high randomness. The randomness of gas particle is higher than particles that are present in liquid phase. So here called evaporation. So again, delta S value is positive. And conversion from solid to gas called sublimation. Sublimation also positive value of delta S. So from solid to liquid, from solid to gas, from liquid to gas, delta S will be positive. And vice inverse case, look, from gas to liquid called condensation, of course, the particles going to have less randomness, so delta S decrease, okay, decreasing in entropy. Here, increasing entropy, increasing entropy, increasing entropy. But this one will be decreasing in entropy, and conversion from liquid phase to solid phase called freezing. From freezing, delta S, it's negative, of course, decreasing in entropy. Entropy decreases. And from gas to solid called deposition. Deposition, we have some phenomena that particles are precipitate from gas phase to liquid phase directly without going through liquid phase. This is called deposition, such as CO2 from gas phase to solid CO2, which we call dry ice. So again, delta S will be negative, decreasing in entropy. Another thing about, look, briefly we can say solid to liquid, liquid to gas, delta S is positive, increasing randomness, Gas to liquid, liquid to solid, delta S is negative, decreasing in randomness, Look, for this reaction, before leaving this page, in all of these processes, which are, look, in all of these processes, 1, 2, 3, 4, 5, 6. In all of these 6 processes, the arithmetic sign of delta H is equal to delta S. It means they have same arithmetic sign because they are physical change, okay? The change happen only in their physical state. Cool. Now let's see. For this reaction, identify the arithmetic sign, identify delta S, which is increasing in randomness or decreasing in randomness. Look, the substance didn't change it, so it means it's not a chemical change, it's physical change. The substance remains same, so it's physical change. Now from liquid to gas, okay, from liquid to gas called evaporation, right? Evaporation. Remember, evaporation, delta S is positive. The randomness, the entropy, increase it. From liquid to solid, from liquid to solid, okay, decreasing in randomness, entropy, decrease it. About this, look, solid to solid, no, don't mention this. Solid to gas, okay, solid to gas, again. from solid to gas, delta S, it's positive. Very easy. Number 2. But, Mr., I know that I have seen many reactions that are both reactants and products. They are present in the same physical state. Okay, give me an example. Like what? Look, we have this. For example, H2 gas plus O2 gas to producing 2H2O gas. So how you can decide according to the physical state? Of course, in this case, we will need the second step. Look, if all substances, reactants, and products have the same physical state, so then we have to focus on the number of mole. Number of mole, please. If we have same physical state of all reaction participants, then we're going with number of mole. Here we have 2 mole. Here we have 1 mole, so the total will be 3 moles. Here we have 2 moles. Number of mole in a reaction means coefficient. The reaction must be balanced, please, okay? So we have 2 possibilities. Going from less number to high number, delta S is positive. It means if number of mole increase, delta S will be positive. Look, if number of mole increase, delta S will be positive. If number of mole decrease, delta S will be negative. Let's see how. Previously here we have 3 moles, but now converted to 2 moles. So number of mole decreases. Okay, if number of mole decrease, delta S will be negative. Okay. But what if we reverse the reaction? Of course, the arithmetic sign of delta S will be reversed too. Look, here we have something. Okay, identify the arithmetic sign of delta S that's increased or decreased, negative or positive. First of all, physical states. Okay, both have same physical states. All of the participants have the same physical states. And now go with number of mole. How you can go according to number of mole? 1 mole plus 1 mole, they give us 2 moles. And now here 1 mole plus 3 moles, so 4 moles. Number of mole increased, so delta S must be in positive value. So increasing in randomness, increasing entropy. So according to entropy, this reaction is spontaneous because of the spontaneity of a reaction likes to have more randomness, delta S positive. Good. Next example, we have ethylene plus hydrogen converted to ethane. All of them, they are present in gaseous phase, so we have to focus on their number of moles. Here 1 mole, 1 mole. They have 2 moles. Here we have 1 mole, so number of mole decreases. So negative value of entropy. Entropy, it means greater than, smaller than 0, but if it's positive, it means greater than 0. We have the following processes. Increasing temperature increases kinetic energy, so it gives us delta S positive value. Look, what if we don't have, if we didn't have any reaction, but there are some information that are useful for entropy identification. Here, positive value, look, increasing in temperature, of course, anytime if you see a question asked by temperature, immediately your answer must be started by kinetic energy. Increasing temperature increases kinetic energy, decreasing temperature decreases kinetic energy. So as much as temperature increase, kinetic energy increase, so entropy increase. Randomness increase because of the particles are moving faster, so there will be more randomness. So decreasing temperature, of course, decreases entropy. That means vice versa. Increasing in pressure. What about pressure? Increasing pressure. Pressure has inverse proportion, indirect proportion with volume. As much as you increase pressure, the volume decreases. So the entropy will be decrease, of course. Look, increasing pressure decreases volume and entropy decrease. Decreasing pressure increases volume, pressure, entropy increase. Look, if pressure increase, volume decrease, delta S will be negative. If pressure decrease, volume increase, delta S it's positive. Look, mister, now delta S is directed with volume, and volume is indirected with pressure. Yes, very good. The process of forming solution, most of the times, they have positive value of delta S, but it depends. We have some special cases. Look, process of forming solution. Forming solution. Forming of solution. If we have solvent and solid in the same physical state, if we have both of them in the same physical state, so this process will be positive. Look, gas in gas. Gas in gas. Delta S, it's positive. Solid in solid. Delta S, it's positive. Liquid in liquid. Delta S is positive. Because both solute and solvent, they have same physical states, so the delta S will be increased. But what if we dissolve gas in liquid? Gas in liquid. Gas, after being dissolved in liquid, the total solution will be liquid. So we just converted gas to a liquid phase. Okay, gas to a liquid phase. So we can go with the first rule. As I told you, conversion from gas to liquid, it has negative value of delta S. But what if we dissolve solid and liquid? The overall solution become liquid again, because the solution going to have the phase of solvent always. The solution will be gas, it will be solid, it will be liquid, it will be liquid, it will be liquid, because of the solvent in all of these solutions, adapt its physical state on the overall solution property. Okay, so because of we converted solid to liquid, delta S will be positive. So process of forming solution most of the times are positive according to delta S. But if we have both solute and solvent in the same physical state, but what if they have different physical state? It depends then. Gas in liquid, negative. Solid in liquid, it's positive. Yep, it's correct. Gas in liquid, it's negative. Solid in liquid is positive. Okay, now let's go through some questions. Entropy decreased. Entropy decreased. In delta S is negative. Decreasing randomness. Well, lowering pressure. Lowering pressure. I remember my lovely teacher, Mr.Höger, told me that lowering pressure, if pressure decrease, volume will increase, then delta S will be increased, so it will be positive. It's positive. Okay. Still, shaking the system. Okay, if you shake any system, you will increase the randomness. So delta S is positive. So it's not. It's not. Lowering the temperature. Lowering the temperature. If we decrease the temp, kinetic energy will be decreased, then delta S will decrease too. So it's positive. It's negative again. Still, it's correct. Increasing temperature. If we increase temp, kinetic energy will be increased. So delta S will be increased. So now you tell me, which one will be the right answer? Which one has negative value of delta S? Of course, lowering the temp. Next question. Decreasing of pressure. Decreasing of pressure. Pressure if pressure decrease. If pressure is decreased, so the volume will increase, delta S will be increased too. So if it's positive, it means it's greater than 0. Okay. So first of all, it's not equal to 0. Okay. It's smaller than 0. No. It's greater than 0. Yes. Very good. So all of them no. So if we decrease pressure, the volume will increase, delta S will be increased, the randomness will increase. So the value of delta S will be greater than 0. Which of the following has the highest entropy value? Okay, which of the following has the highest entropy value? So here you cannot select one of them directly. You have to compare each two answers together. First of all, start by comparing A to B. Solid by comparing to gas. Which one the randomness increased? Which one has the highest randomness? Of course, gas. So it's go out, please. Now, answer of B with C. Gas to liquid. Gas to liquid, of course, again, gas wins. So go out liquid, please. And now gas with aqueous solution. Aqueous solution, it's liquid also. So gas has more entropy. So let's get that. But mister, what? If we don't have gas, here we have another liquid. Liquid something. For example, HCl liquid. Okay, look. Or another thing. Comparing liquid to aqueous. Converting liquid to aqueous. Okay, look. Liquid, it means pure substance. But it's solution. So delta S for this is higher than this. So in this case, delta S is positive. So comparing liquid to aqueous, aqueous has more entropy has more randomness than the liquid. A mixture of gas by comparing to an individual gas. We have a mixture of gas. Here, mixture of gas. Look, here, mixture of gas. Okay, please understand. Here we have mixture of gas, and here we have individual of gas. Individual gas. Look, suppose that we have a reaction. Here we have mixture of gas, A plus B. Here we have one gas, C. So we can go with the number of mole. Mixture of gas, of course, has higher entropy comparing to individual. Individual, less entropy than this. But the question is about mixture of gas. So can you tell us about entropy of mixture of gas by comparing to individual? Higher entropy. Higher entropy, of course. Higher entropy. Another thing. What if we compare individual gas by a mixture of gas? Less entropy. In that case, less entropy. So, look. Let's get back to some detail. Look, here to here, delta S, it's positive. Here to here, delta S, it's negative. Negative. I have said negative. Okay. Which of the following has negative value of entropy? Look, negative value of entropy. Decreasing in entropy. Okay. Evaporation, 1 mole of liquid. Liquid to gas. Delta S, it's positive. Freezing, 1 mole of liquid. Liquid to solid. Delta S, it's negative. Here, rising the temperature of water, rising temperature. Temperature increase. If temperature increase, kinetic energy will increase, so delta S will be positive. None of them, okay, none of them. So the right answer will be B. The right answer is B. B is the right answer. Processes in nature are driven into two directions. Toward, look. Toward least enthalpy, it means delta H negative, as I told you, and largest entropy, delta S, is positive. So if we have a reaction, it will be spontaneous according to negative value of delta H, and will be spontaneous according to positive value of delta S. Okay? Look, we have this equation. We have this question. According to delta S factor, this reaction will be, look. We have this reaction, first of all, according to delta S. So let's identify delta S of this reaction. Delta S of this reaction, gas, number of mole. Here we have 2 moles. Here we have 1 mole plus 2, 3 moles. Okay, 3 moles. So delta S, the overall delta S is increased positive. Look, mister. Now, draw this. Okay. This is for forward always. Or I will tell you in easier way, really. We have more easy way than this. Look, delta S, it's positive, right? So if the reaction has positive value of delta S, it will be direct. It will be direct. If the reaction has positive value of delta S, it will be direct. But if the reaction has negative value, it will be reverse. Look, positive value of delta S will be direct. Negative value of delta S will be reverse. So that means reverse, yeah. It will have reverse direction. It will go through the reverse direction because of the overall entropy change of the reaction is positive value. So, sorry, it's direct. Just now I say it's direct, of course, forward. Direct. Look, if we have a reaction, if delta S is positive, it will be direct. But if for the reaction, if delta S is negative, it will be reverse. Good? And now this reaction has positive value of delta S. Okay, it's forward, it's direct. Look, which of the following reactions favored the backwards, reverse direction according to delta S factor. According to delta S factor. Okay, we have 4 reactions. Which of them favors forward direction? It means forward. Which of them favors reverse direction? So when the reaction goes through reverse direction, if it has delta S negative. Okay, look. Delta S for this reaction, S to aqueous. Okay, delta S, it's positive. Because of it's positive, so the direction will be direct. Forward. Here, H2O liquid to gas, delta S is positive. So the direction will be direct. Forward. Here, NH3, look, gas to aqueous, or liquid to aqueous. Look, how you can decide this type of reaction, okay? So here, don't focus on liquid to aqueous because we have gas converted to aqueous, so delta S is negative, right? Delta S is what? Delta S is negative. So because of the delta S value of this reaction is negative, so the direction will be reverse. Backward. Here, 2NH3 gas converted to gas. So focus on number of mole. Here we have 2 moles. Here we have 3 with 1, 4 moles. Increased number of moles, so delta S, it's positive. So it's forward again. No, please, forward again. So now, which one favors reverse direction? It means which one has negative value of delta S. Let's go to reverse direction. This one. Okay, according to delta S and delta H, identify the favored direction of this exothermic reaction is exothermic. So delta H, it's negative. And now let's identify delta S also. Delta S, gas. Focus on number of mole. Here we have 3 moles. Here we have 2 moles. Number of mole decreased, mister. Okay, so delta S is negative also. And now, look, for a reaction. If delta S is negative, it will be reverse. If delta S is positive, it will be forward. Okay, I have told you. Balam, sorry, but according to enthalpy, if enthalpy, look, if enthalpy it's negative, it will be forward. If enthalpy it's positive, it will be reverse. And now for this reaction, delta S, it's negative. Mister, because of delta S, it's negative, so it will be reverse. So according to delta S favors reverse direction. And now delta H it's negative. Okay. According to delta H, if delta H is negative, favors forward. If delta H is positive, favors reverse. Okay, according to delta H favors forward. Cool. I think it's super simple. It's a piece of cake. It's simple as a piece of cake. Okay? And I have told you this note many times. During physical change, both delta H and delta S have the same arithmetic sign, negative or positive. Look, conversion liquid to gas phase is evaporation. Evaporation is physical change. Evaporation, so it must, I mean the value of delta S and delta H must be present in the same arithmetic sign, and for the others it will be the same. And now I'm going to stop here. Gibbs free energy. Gibbs free energy, inshallah, I'll continue from Gibbs free energy and we will finish section 2 of chapter 4 in more detail, God willing. بەم شێوەیە کۆتایی بەوانەی ئەمڕۆمان دێنە قوتابی خۆشەویستەکان هیوادارم سوودتان لێبینی بێت هەنا ئەوەندەیە بزانن کەوا دراڤین فۆرسەکان بریتین لە چی لە دڵتا S, دڵتا H, دڵتا G کامیان ئەنسێرتنە دڵتا S and دڵتا H کامیان سێرتنە دڵتا G. I'll tell you in more and I'll give you more detail in next lecture inshallah, and be careful about my notes. However, I don't like to give you more notes because of I know that you're going to confuse it during the final examination. But you know, for you it's very good to know these. بەم شێوەیە کۆتاییمان بۆوانەی ئەمڕۆ هینە تاوانەی داهاتوو بە خواتان دەسپێرم. خواتان لەگەڵ.